Hello friends, this is Altaf Qureshi. Welcome back to my channel, and this is the part third of the VPN series on my YouTube channel. And before we begin, there's a kind request from my side that to like, subscribe, and share my channel as much as possible. And if you like my contents, please do comment on my videos regarding what you like in my videos and what you want in my future videos, right? So I am working hard to record these sessions and upload to the YouTube. Uh, so that's it, yeah, guys. So support me. That this is how you can support me. Okay. So in this video, the agenda would be this IPSEC over GRE. In the last video, we did the GRE, right, tunneling, and we saw that that is clear text, and now we will put the IPSEC encryption and encryption hashing and the authentication over GRE, right? Then we'll see the advantages and disadvantages, and yeah, obviously the demonstration. So for that, I have the old the topology that we were running, right? So in this, what we are doing is we are running this tunnel interface between this is tunnel interface 10, right? Tunnel interface 10 that we configured. And then we specified the IP address for this tunnel interface. Address was 192.168.1.2 on this side, and here also I have the tunnel 10 interface tunnel 10, and that has an IP address of 192.168.1.3, right? So that is the address. Then we specified the tunnel source. For tunnel source, you could specify the exit interface as well as the IP address. So here I will specify 1.12.1, and then you specify the tunnel destination. That is your other side, right, with which you want to form the tunnel, right? Tunnel destination for me in this case is .1.23.3, right? So this side is your tunnel source. You can say your interface, right? Interface Ethernet 0/0, right? This also you can say, and then you have the tunnel destination and this side as destination as 190. Oh, not the 192 series. It should be your public IP 1.12.1, right? So this is the overall like summary what we did in the last video, right? So what we saw is the data, right, traveling between these two endpoints, right, peers, right? So what was happening is it was clear text, so we could see the data. So if I go to my this Wireshark, right, I'll go and capture my Wireshark, and you can see, right, from R1 from R1, if I go to R1 and ping the other side 192.168.1.3, that is the other side. Let me check my analyzer is working or not. I don't think it's working because I can't see any traffic. There should be traffic. Let me just restart it. VC dump is working now. Let me ping once again. So you can see, right, this is the ICMP. You can see the ICMP, then the GRE, sorry, the data in inner source, inner IP header, then the GRE encapsulation, then the outer IP header, right? So the head that wait, let me just draw the packet. Yeah. So what's happening is you have the ICMP data, right? ICMP. Okay, this is ICMP, and then you have your inner header, which is going from 192.168.1.1 to 192. This is 192.168.1.3, right? Then you have your GRE header, right, and the external IP address, which comes from 150.1.12.1 goes to 150.1.23.3. So guys, this outer header, where does it come from? So you remember, right, when you say tunnel source and tunnel destination, right? So this is why this is very uh, important. So the outer header for this GRE comes from this source and destination. So source is this, destination is this, that you specify in R1, right? So this is very important in a sense that if you specify this as wrong, your tunnel will not be working right on both sides. So that's what we had already done. Now we have to make this traffic be secure over internet so that anybody on the internet is not able to see the data, right? How you do that? You use the IPSEC suite of protocols over GRE to encapsulate, encrypt and authenticate and hash, right? All this stuff. So let's see how you do it. So for that I have to grab my notepad. Go to my notepad and okay, let me just grab my notepad. So I have my notepad here. Let's go to R1. What we do is we have let's just brush up quickly. So this is for R1, right? Yeah. So this is for R1. So what is the first thing that you do is phase 1 policy, right? That is a phase 1. How do you configure it? Is crypto IPSEC policy and the policy number, right? And then you say encryption. I'll use 3 days. And then you say authentication. I say pre-share. Then you say hash. I say MD5. Then you say group. That is your 2, right? Done. Next one is your authentication key. Yeah, authentication key. How do you do that? That is again crypto IPSEC. This is phase 1, so IPSEC key Cisco 123, and then you say the address. That should be your public address from R1 to R3. Okay, then what next comes is your uh, transform set at phase 2, right? So you say configure phase 2, and that is your phase 2 is your transform set. So I'll write down in bracket as transform set, right? How do you do that? Is crypto. So phase 2 is IPSEC, right? Phase 2 is IPSEC. So you specify crypto IPSEC transform set, name it tset. Then you say ESP des and ESP MD5 HMAC, and then what you did was in your native IPSEC you used to create that uh, access list, right? But here you don't create the access list. What you do is you create a IPSEC profile. Okay, so because this is your what you say is your you run your dynamic protocols over it, right? So you use the profile here. So step 4 would be configure the IPSEC profile, right? FILE profile. How do you do that? Is crypto IPSEC profile and then you name it. So I say iprof, enter, and then you call the transform set in here. Transform set, name as tset. Because in the crypto map, right, you used to call the access list, you used to set peer, and you used to set the transform set. But here only you need the transform because you are not using access list, and the peer is already specified in your tunnel interface configuration, right? Tunnel destination, that is your peer. So that's that, and now you apply this to the interface, right? Apply profile to the interface. Apply profile to the interface tunnel. Okay, what you do is interface tunnel 10. How you specify, go into inside the interface tunnel 10 and say tunnel protection IPSEC profile, then the name. Okay, iProf. That's it. Done. This is your R1. You say enable and you say config key. Okay, so let's copy and paste all of this to R1. As you can see, from R1 to, we close this, and so we have the ERGRP going on, and you can see the R1 to R2, you can see the Cisco ERGRP hello, right? And then you have the internal IP, then the GRE header, then the GRE encapsulation, external IP header, right? So this is 98 bytes, but when you apply this GRE over it, it's around 52 bytes. Let's see. So I'm going to my, I'll close this. No, I will close this. I'll go to my R1 and copy paste all of this. R1, right? And I say write and write memory. So this is R1. Now let's do the same for R3. So for R3, I'll copy all of it and let's change something. R3, paste, and phase 1 is same. Phase authentication, for that I need to change the 12.1. Phase 2, let's keep this as HMAC, and then iProfile, this is fine. Done. Okay, let's copy paste this to R3. Okay, and let's go here, R3, and let's do that, and write memory. Okay, I did a mistake, so that I did intentionally. Okay, just to let you know what we learned in the IPSEC. Do we remember that or not? So this tunnel will not be formed, and you can see the packet is getting dropped at my 7th and 8th. Okay, 7th and 8th. So what is, just try to remember what is exchanged in 7 and 8. Do you remember? Yes, if you remember, it's correct. It's the phase 2 policy, right? So we need to check the phase 2 policy on both the sides. So if I go here, show run section crypto, right? I can see the policy is IPSEC transform set, ESP DES, and SHAMAC. If I go here, specify the same thing, show run section crypto, and I can see that this is MD5. So this I did intentionally just to show where the packet fails, right? So what I need to do here is I need to go here, R1, and if you see that the neighborship will be also down, show IP ERGRP neighbors. If I do, I have nothing. Okay, so I'll do config T and I'll paste the crypto this thing and write. Now if I see after some time, that was around 90, I think 96 or 98, I don't, 98, right? Now I should see the hellos. Yeah, that what do you say, the IPSEC camp is successful. Now I see the hellos going on. Let's wait for certain time, or what you can do is you can clear here using the clear crypto sessions and clear crypto SA command. So these are the two commands that you can use to clear your sessions and clear crypto SA. I did the sessions, now SA. Nice. Okay, I can see the neighborship will go up and down. Yeah, I can see all my 9 packets, 1 2 3 4 5 6 7 8 9. 6 main mode, 3 quick mode, right? and I can see my packets flowing now. Let's wait for some time and let's grab one. So you can now what you can see is just the outer header, right, and the ESP, and you cannot see anything beyond ESP. Just let me show you what it is actually, so you don't know. Just remember the size. Okay, this is 150 bytes, the hello. Okay, um, it was earlier 98, now it's 52 extra because of the IPSEC header, right? So let me show you the explain to you quickly the header, how it looks as of now. So if I go here, grab my pen. So now what you have is the EIGRP hello, right? And then you have the internet source and destination. This is your 192 going to 160, 192 168 101 going to 192 168 1.3. Then you have your GRE like this, encapsulating this thing. It has the outer header 150 1.12.1 going to 150 1.23.3. After that, what you have the ESP, right? ESP, and it has again the headers, so source and destination. The source is 150 1.12.1 going to 150 1.23.3. This is taken from the uh, tunnel source and destination, right? Okay, but now what has happened is, because of ESP, this all is encrypted. Okay, this is all encrypted, so that's why you are not able to see anything beyond your ESP. So if I close this and grab one, so you can see ESP and nothing behind that, right? And the outer header. So we have successfully encrypted our data. So only person that can decrypt is the R3. Okay, let's check on this R3. Let me close this and let's go to R3 and specify the command show crypto IPSEC. Yes, I can see the IPSEC. Okay, you can see this. Right. Also R1, if you see show IP, show crypto IPSEC SA. Okay, so let's generate some packets. I mean, we have the packets actually generated, the hello packets. You can see encrypt and decrypt, right? So let me ping. So if I see my routing protocol, right? So IP route, as I am running the EIGRP, so I should have the loopbacks here, right? So I have 10.1.3 and 10.1.3, 10.3.3.3. So I can ping both of them. Ping 10.1.3.3, source of my loopback 0, it will reach. And if I try to ping 333, that will also be successful, even from loopback 1 and from loopback 1. This one all is successful, right? So if I see the crypto IPSEC SA, the packets encrypted have been increased. Okay, so this is the IPSEC over GRE. So like this, we have encrypted our data traffic that we have to share to our peer over the internet. But the problem now is the packet size, right? If you see the packet as of now, I've shown you, it is encapsulating twice, right? So the IP header is being attached twice. To overcome that, you can see the size is as of now 150 bytes, right? So what is happening is, let me show you. So this EIGRP hello, right? EIGRP RP hello. the same thing that I showed you. Just let me show you. This is the internal header 1.1 going to 192.168 or 1.3. Then you have the GRE header encapsulation. Then you have this 151.12.1 going to 151.23.3. Then you have the ESP. Then again the same source and same destination inside this header, right? What is happening is this takes around your 16 bytes and this takes your 8 bytes. So if you remove this, because the routing is based on the outer header, right? And beyond this is encrypted. So we can remove this IP header. How you can do that is by changing the mode of the tunnel from tunnel mode to transport mode. What transport mode does is it removes this GRE IP header, okay, not the GRE header itself, just the IP side. So that's 16 bytes. So as of now we have 150 bytes of hello. So this should be 134 now. When you minus that 16 bytes. Let's do this. How do you do that? First, let me show the mode, which is tunnel by default. You can see when you see the IPSEC, and you can see in use tunnel. So where you change this is going to the phase 2 transform set section crypto. If I see, you can see this is the transform set, and you can see the mode is tunnel, right? So I have to go here into this this one, and I have to specify mode transport, and the same thing I need to do here also. Mode transport and write, and I have to say clear crypto SA, clear crypto session on here as well as okay. I did this command wrong. I have to wait for a certain period. Okay, let's see. I have already cleared from one side. Let's see the size now. You can see this is 134 now, right? Okay, as I said, right, when you remove this, so now the packet looks like, let me show you. Now the packet is like let me delete this and let me open my this whiteboard. So now the packet looks like you have the hello. Okay, you have the hello, and then the header, which says 192.168 1.1 is going to 192.168 1.3, and then you have now the GRE, but you have removed the IP header, so now you have the ESP and the external header, which says 151.12.1 is going to 151.23.3. So this is the total header that is right now of 134 bytes. So after removing this header, don't you think this GRE header is of no use, right? So we can remove this also and reduce again 8 more bytes. How you do that is you go to your tunnel interface tunnel 10, and because by default it's GRE, right? So you can remove that by saying tunnel mode IPSEC IPv4, tunnel mode IPSEC IPv4. So when you issue this command into a interface tunnel 0, it should the hello packet size should be reduced to 126 bytes. Let's see this in action. Okay, close this, close this. Okay, you can see 134. Let's go to your R1 config key interface tunnel 10, and you say tunnel mode IPSEC IPv4. That is the command that you say. So I should specify the same command on the other side also. Config key interface tunnel 10 and the same and right. So I should have neighborship go up and down. As you can see, the neighborship is up again, and let's wait for certain period of time so that this I can see it's still 134. Let's wait for some time till that tunnel knows. Okay, let's see here also show crypto IPSEC SA. Let's verify we have the transport mode. Okay, it goes to tunnel mode because I set the IPSEC IPv4, right? And I had to show it before this mode, right? So you have now 126. So let me remove this from my interface and let me show you the transport mode that we did, right? I didn't show you that it changed. So I have to go to my interface channel 10 and say no to this command. So let me copy this again into the R3 and quickly go to my interface channel 10 and paste this command. Let's wait for this neighborship to go down and up. It takes some time for the routers to negotiate, right, on parameters. So if I see here show crypto IPSEC SA, I want to see my mode transport, right? Nice. So that's what I wanted to show you. So again, the packet size should be 134. This is the packet 134. Now when I go to my interface config key interface tunnel 10 tunnel mode IPSEC IPv4 and R3, and also I need to specify the same command on R1, right? Here and this, and let's wait for the neighborship to change from down to up again. So after waiting for a certain amount of time, I will see that this mode will turn to the size will go to 126 bytes because we have removed that header itself. So if I show you this thing right now, what we have done is, let me take my eraser. What we have done is we have removed this completely. Now what it looks like is this total size is 126 bytes. If we go to the Wireshark, you can see this is 126 bytes. Okay, so you first it was 150 bytes. Then we removed the 16-bit IP header of the GRE, IP header of GRE. It became how much? It became 134. 150 minus 16 is 134. Then we removed the GRE header itself, that was of 8 bytes. It became 126 bytes. Now one more last thing before I end this video is, now the header that we removed, right? So that was GRE, and that is already removed. So IPs for that what do you say? for the IP header to be removed, we specified which command? We specified we changed the mode to transport, and to remove the GRE itself, we did was we changed the interface tunnel mode to IPSEC IPv4, right? But now last thing is, don't you feel when you don't have the header itself, IP header is like, I mean, you don't have the GRE header itself, so you will not have the IP header, right? So we can change this mode to tunnel. But you have seen by default it becomes, when you specify this command, the mode gets changed to tunnel mode. But anyways, you can do that. You can go to your page 2, do show run section. If I go back here, section crypto, so you can go to your, yeah, you can see more transport here, right? You can go here and say more tunnel, and this will not change anything because already the size of that is 126 mode. So okay, more tunnel, it should be more tunnel. Just to show you that what is the working of more tunnel and more transport. I hope this clears the logic behind mode transport and mode tunnel. Now if we go to your header side, it is still 120, because with that mode with the tunnel interface, we type that tunnel mode IPSEC IPv4, right? That removes the GRE header itself, and when you remove the GRE header, the IP header will be removed by default. So that was that. Now let's talk about the advantages and disadvantages that we get from the IPSEC over GRE. Let me just erase these things. Okay, now we first of all, what we did was native IPSEC. So native IPSEC, the problem was the one is that the ACLs, right? So you had to specify ACLs for every LAN segment to talk to the other side. That has to be encrypted. That was cumbersome, and also we were not able to run the let me grab a pencil with black. Okay, this is fine. So what we did was on the IP header, right? Not the IP header, in the IPSEC, native IPSEC, right? In the IP, okay, let me grab the pencil. In the IPSEC, you can say native IPSEC. Uh, the problem was for the interesting traffic. For the interesting traffic, you had that ACL, right? ACL, and because of that, the scalability scalability was the issue, and also when you have new LAN segments, you had to add the ACLs. New LAN segments add ACLs, right? So that made the configuration cumbersome. Okay, so that made it difficult. So, and also you didn't have the option to run. I'd say no option to run run dynamic protocols. So we came to GRE, and we had a point to point tunnel interface over which we could run, over which we could run dynamic routing protocol, right? routing protocol like EIGRP, etc., OSPF, etc., right? EIGRP, OSPF, etc. But then this GRE was clear text. So what we did is we uh, applied IPSEC on this GRE. So this became IPSEC over GRE. Now you still have some problem in this. So let's say what you do is you have these two sides. Okay, let me just remove this. You have these two sides. You have R1, you have R3, and you have R4 here. Okay, R1, R4, R3, and you have the ISP, that is your R2. Anyways, so this is connected to all three like that. So you have a point-to-point link here to here. So now what? Now what if you want to connect R1 to R4? Can you do that? Just imagine. You need to have a separate interface tunnel for this. So here then you need to have interface tunnel say 11, and here interface tunnel 10, whatever. This is locally significant, right? Then again all those commands, right? Tunnel IP address 192.168.1.4 no 5, and this one should be 192.168.1.4, etc. So if this wanted to have to this again a new interface tunnel, so this was this is again that scalability, right? Not scalable. So for this issue, GRE came up with another concept called MGRE, that is the multi-point GRE, generic or routing encapsulation. So we will see this in our next video. Okay guys, so that's all for this video. In this video we saw the IPSEC over GRE, advantages, disadvantages, and the demonstration. So guys, again, before like signing off, I have a request. If you like the content of my channel, kindly like, subscribe, and share my channel as much as possible. And do put your comments in my comment section, what you like in my videos and what you want on my channel. Okay guys, see you in my next video. Thank you. Bye bye.